Okay, we are talking about lecture 6 here, which we are going to focus on our distance formula, identifying quadrants, as well as our midpoint formula. So this first video, we're just going to do the identifying quadrants. After we get that done, we're going to start working with our distance formula. And there's a couple test questions that kind of deal with that distance formula that we're going to look at. So go ahead and get rolling here. First off, with your guys' quadrants that you have, big thing you need to remember, yes, we move counterclockwise, but we need to make sure that we know exactly where quadrant 1 is as far as where we start. So the way that I think about that is when you guys started out as younger kids, the first chart that you started with was quadrant 1. So this might be 10, 15, 20, okay, and this was 1, 2, 3, and you guys would make like line graphs where different values were changing throughout. So the first graph that you guys learned was in quadrant 1. So this is always where we start as far as our quadrant 1 goes. And then we just move around counterclockwise. So quadrant 2 is over here, then quadrant 3, and then quadrant 4. And those are going to come into play when you guys deal with your true and false questions. So that's why we want to make sure that we know those there. Okay, now to the distance formula, the fun part. Okay, the distance formula was created by using Pythagorean theorem. So the Pythagorean theorem says that a squared plus my b squared needs to equal my c squared. Okay, so I've got the distance between these 2 points here. Okay, and that distance between the 2 points, this distance right here, is going to be our c. That is our hypotenuse. So we need to create then a right triangle. So to create that right triangle, I can drop myself down and I can go straight across. And then based on what I've created there, okay, I have created now a right triangle where my C is going to be that distance. So this point down here, I need to figure out what it is. Well, I started up here at this point, x sub 2, y sub 2, and then I have moved downward. I moved down, okay? So since I'm moving straight down, my x sub 2 is going to be the same because I have moved straight down, okay? And then for this one here, I am moving to the right. So my y value would not be changing if I'm moving to the right because I'm not going up and down. My x value, however, would be changing. So since my y value doesn't change as I move across, that means the y value of this point is y sub 1. Okay? So my third point right here is my x sub 2 and my y sub 1. Okay? So if I want to figure out what this distance is here on this line, okay, in order to figure that out, I would need to know what is the difference between my y values. So I would say y sub 2 minus y sub 1, that is going to be my distance. So this here would be my b value, okay? Same principle down here. I need to find the difference between my x values. So I can do x sub 2 minus x sub 1. And that would be my distance between these 2 points here. So finding my distance formula then, I can plug in my a, which would be x sub 2 minus x sub 1. Oh, that doesn't look very good. X sub 2 minus x sub 1. And then that needs to be squared plus my v value we said was y sub 2 minus y sub 1 squared equals, now what is c? Well, c is my distance between those 2 points squared. Okay, and we've almost created our distance formula here. The only thing is this is your formula for distance squared. So we'd want to get rid of that squared by taking a square root of that. So we end up with our d equals, and then it is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And all of that is underneath a big old long square root. So that right there is our distance formula, and that's how we use the Pythagorean theorem to find it. Okay, so let's practice using the distance formula. Okay, I've got to find the distance between these 2 points here. Now, first thing I want to point out is on this one here, they put absolute value signs. I've always used parentheses. You don't need the absolute value because the squared is going to get rid of your negatives anyway. So I always use parentheses there. We need to determine a second point and a first point. I always like to make this my second point, and then I can make this my first point. Let's do this in red, just it's a little bit easier to see. Okay, so I'm going to fill this out then. My x sub 2 would be a negative 2 minus my x sub 1, which would be 1. So I got negative 2 minus 1 squared plus my y sub 2, which would be negative 5, minus my y sub 1, which would be negative 6 squared. And that's all underneath my square root there. Okay. Negative 2 minus 1 gives me a negative 3 squared, plus negative 5 plus 6, okay, gives me a positive 1 squared, still all underneath the square root. And I get a negative 3 squared, which would be 9 plus 1, and that gives me the square root of 10. And that would just be my answer. Remember, if it was like a square root of 20, we do 2, 10, 2, 5, pair of 2's. So that's square root of 20 is just 2 square roots of 5. Well, if I break down 10, that's just 2 and 5, and there's nothing in common. So square root of 10 is as low as we can go. Okay, so that is using your distance formula right there. Next video, I'm going to do a video of each test question just so you guys have easier to refer to back if you have questions on that specific test question.